Welcome to Chapter 1 of AP Stat. This section is called Data and Variables. We're going to be talking about the building blocks of really everything we're going to be talking about for the rest of the year. Let's talk about the population and the sample. This is what statistics really, when you boil it down, is all about, at least what we will be studying this year. What is a population? A population is the set of all possible cases we could consider, all right? For example, in this section, we're going to be looking at all online music purchases, all right? Every online music purchase that people have made in a given span of time. A sample is a subset of the population, so not the entire population. Usually in statistics, you cannot study an entire population. It's generally considered to be an impossible task. But one thing you can do is you can sample from that population and learn a bit about the population from your sample, assuming that your sample fits a couple of categories that we will repeatedly refer to for the rest of the year. Honestly, it's basically applied common sense, but it's also very easy to sample badly, especially if you cut corners. More on that later. So in stats, we understand that we cannot study the population, as I've said, so we choose a sample to analyze, ideally one that resembles the population in several ways that we will discuss, so we can learn about the population. Now let's look at some data. Data are any collection of numbers, characters, images, or other items that provide information about our topic of interest, all right? So we're going to see a data table below, you can see it already, of possible online music purchases. And some of the approximations of band names are kind of silly, like, Coldplay, Red Hot, Chili Peppers. Yeah. I don't know what people were thinking here. Anyway, there you go. That is a data table. There are all kinds of variables going on. You have everything from order number, what on earth is going on there. We have the name, I guess, of the person who purchased it, the state or country. So we got states if we are in the United States. We got Canada over here as well, a little international action there. We have the price, different prices, area codes. Download, I'm honestly not sure where this is. Maybe it was where the music was recorded. I don't know whether it was a gift or not, whether it was a download for themselves or for someone else. ASIN, no idea, some kind of identification number. And you have the artist, either real or possibly fictitious, knockoff bands. All right, let's talk a little more about these data. By the way, data is a plural word. The singular is datum or datum, D-A-T-U-M. That's a singular point. Data is a plural word. Now that I've said that, I'm probably going to use data as a singular word many, many times. Everyone does, but for the record, when you speak of data, it is a plural word. Like when you refer to the data, you're referring to many points, not just one, okay? So now that I've said that, of course, I'm going to use it as a singular word. My apologies when I do. All right, rows of the data table correspond to cases about whom we'll be recording characteristics. So each one of the rows here, this order number, our friend Kathleen H. from Ohio paid 99 cents from this area code from a song that was downloaded from here, recorded there, I don't know. It was not a gift. This ASIN number and this knockoff band from my generation that is still recording, I guess, half-decent stuff. So that whole row is a case, all right? Respondents, people who complete a survey, all right? People who complete a survey, if you're ever handed a survey, you are a respondent. If you're giving a survey, anyone who responds to your survey are respondents. If these data were collected from a database, it's kind of like every one of the individuals in this list is a respondent. All right? Also, We could have subjects, participants, experimental units, all right? These are people, animals, or objects that are part of an experiment. When we talk about people who are involved in a statistical experiment, and we see the word experiment, that's a little scary. We're doing experiments with people. Trust me, it's not scary if you do it right, if you follow some guidelines that we talk about in statistics, all right? If we're talking about people, we talk about them as either subjects or participants. This is the friendlier word. Experimental units, when we talk about experimental units, we're talking about critters, we're talking about animals that are used in experiments, we're talking about objects, that sort of thing. But when we do an experiment that involves people, we use nicer words like participants or subjects. All right, cool. Just a little formality there. So cases could involve just respondents or people who are involved in an experiment, or critters or objects that are involved in an experiment as well. All right. Records, like entries in a database. All right. So these may be respondents. They may have filled out some information to land in this database. Well, honestly, more likely, they were just automatically sorted entries in a database. Someone makes a purchase. All their information goes in a database for statistical purposes, perhaps. There you go. So these are records. The columns of the data show variables. All right. These are characteristics, numbers, or quantities that can be measured or counted given a set of data. All right. So we talked about how each row, like the row involving this order number and Kathleen H, all the way from left to right, is a case. All right. But if we were to look vertically, order number is a variable, okay? And each one of these order numbers is a possible result we could get when looking at this variable. This variable here, name, there are a bunch of names that we get. These are the values that name could assume. These are the values that the variable state/country could assume. These are the values that price could assume, and so on and so forth, all right? So the cases in this table are each of the orders, and the variables are, well, as I've said, order number, name, state, country, price, area code, download, is it a gift or not, ASIN, whatever that is, and artist, real or fake. All right. So, for example, artist is a variable, all right, but that first row is a case. Good to know the difference between those things. And mind you, artist is the variable. Coldplay is a value or characteristic that an artist can assume. Artist is the variable here. Everything that falls under that category is a value or a quality or something like that that artist can assume, but artist is the variable. All right, now let's talk more about variables. Identifier variables. This does not come up very often. You may not see this at all for the balance of the year, but it's a good place to start. Identifier variables, they identify particular cases. They have no meaningful use in data analysis, all right? Order number, this chaotic mess right here has, as far as I can tell, and as far as our textbook can tell apparently, no value in data analysis. All right, we're not going to be analyzing these little numbers here to learn something special about Kathleen and Samuel and Chris and Monique and Will, or any of the, much less any of the states or countries they live in, or any of the other information this table gives. So, yep, order number, identifier variable, even name. I don't know. It's not really helpful in the analysis. Categorical or qualitative variable. All right. These variables, this is where it starts to get a little interesting. All right. These explain what group or category each individual belongs to. All right. So we look at state/country here. Okay. And we got Ohio and Illinois out in the Midwest. We have Massachusetts in the Northeast, another Ohio, and a totally different country. We have our northern neighbor, Canada. It may be of interest to us to determine whether folks in the U.S. have different music tastes than folks in Canada. It also may be of interest to us whether folks listening in the Midwest have different tastes than those in the Northeast. all right? Those in New England, okay? Another example, area code, all right? Now, these numbers are kind of chaotic, I admit, but is there any association between certain area codes and certain music tastes, all right? This is an extremely laughably small sample of all of the downloads that exist. Perhaps if we had a larger sample of maybe several hundred or several thousand music downloads, then perhaps we would make an association between certain area codes and certain tastes in music, right? Download. This is where it was recorded. Is there a relationship between certain states and certain preferences of music and where they may be recorded or where they may be downloaded from? I don't know. Whether it was a gift or not. Are people more likely to gift certain kinds of music or keep certain kinds of music to themselves, right? And of course, artist. That is a qualitative variable. That, of course, you could say, do people from Ohio, are they partial to cold space play? People from Illinois, are they big fans of Red Hot, Chili Peppers? I don't know. You could see if there's an association between artist and the state or country that people are ordering from. Quantitative variable, all right? When people think of variables, we usually think of numbers, right? Now, these are the variables that actually have to do with numbers. We're not talking about qualities anymore. A quantitative variable records the amount or degree of something with specific units, all right? That's really important. If you have a number that does not have units, it is very likely, almost certain, you are not talking about a quantitative variable. You're talking about an ordinal variable, and we'll talk about that a little bit later, right? For example, price, all right? Price is going to be, looks like all of these were downloaded from places in the U.S. or recorded from places in the U.S. The price is going to be in U.S. dollar, okay? That is a meaningful unit, U.S. dollar, so that means price is a quantitative variable, okay? Sometimes variables can be treated like categorical or quantitative variables depending on what statisticians want to know, all right? So if you see a number, like I alluded to a little bit ago, when talking about identifier variables, these numbers right here, or talking about that ordinal variable when there are no meaningful units like US dollar, sometimes we see a number and we think, oh, this must be a quantitative variable, right? It's expressing a quantity. No, not necessarily, okay? And sometimes it just depends on what statisticians want to know, all right? That determines whether a variable is categorical or quantitative, all right? So, for example, age could be used to group you into a category of consumers, all right? So if you were listing the ages of these people, assuming ages were accurate in the database, if people were grouped by age, then you could see if you can make an association between an age bracket and a particular taste in music, all right? You're using age as a category, all right? Talking about kids, talking about teens, talking about 20-somethings, talking about us old folks 30 and up. So age could be used as a category, even though age is a number, all right? And spans of ages, like teenage years, 20s, 30s, 40s, whatever. They're all numbers, okay? But we can treat them as categories. They could also be used to show trends in purchases, all right? And at that point, you would want to use it as a quantitative variable. So for example, if we were going to make an XY axis, all right? And on the X-axis, we had the age of the person, and on the Y-axis, we had number of purchases. Maybe we could show, as age increases, number of purchases for this artist decreases, and we would express that as some kind of a relationship. That's a little different than what we did before. We're not grouping people into categories. We're seeing if there is a trend as age increases, Do purchases increase or decrease? Are people more fond of certain music or less fond of certain music as they get older? All right, there you go. So depends on what statisticians want to learn, right? Not all variables with numbers are quantitative. Area code, all right? We're not going to be looking at area codes as a quantitative variable, all right? That I said before was a categorical variable. An area code refers to a place. It doesn't refer to a quantity. It's a number assigned to a location, right? Another good example of a number that is used as a category, assuming that all of you have been to a wedding before, feel like that's a safe assumption, y'all got table numbers, right? And each table number has, well, a number, right? But that number is not counting anything. It's not like table 10 is better than table 5 or worse than table 5 or further along than table 5. It's just a designation for where certain people should sit, all right? Maybe that has something to do with the order of people getting up, but again, it's just a place. It's a number that designates a place, all right? So we don't want to treat all numbers as quantitative variables. That's really the thrust of what I'm getting at. All right, little recap here of something that the book discussed prior in this section, but I have omitted, so this is the first time we're seeing it. A Consumer Reports article about 126 tablet computers lists each tablet's manufacturer, cost, battery life in hours, operating system, one of those, and overall performance scores 0 to 100. All right, let's look at those variables, starting with manufacturer and going all the way to performance score. There are a handful of variables there. Are those variables categorical or quantitative? All right, or are they something else perhaps? Or are they just identifier variables? Are they ordinal variables? Are any of them ordinal? So be careful. Make sure you think about each carefully. And if there are units, if you're dealing with a quantitative variable, feel free to list units as well, all right? And then it says describe the why of this investigation. Just think about why we would want to be studying data about this topic. All right, so take a minute or so, think about each of those variables, categorize them as qualitative, quantitative, or perhaps something else. One of these, at least one of these, is going to make you think. Yeah, take a moment, give it a go, and see if you can identify all of these variables. Okay, if you, assuming you need more time, if you didn't pause the video, if you think you have all the answers, we're going to look through all of these variables and see where they land. Okay, so let's look at these variables here. Manufacturer is categorical, all right? That is a category. Cost. That's quantitative. It is measured in US dollar. Battery life is also quantitative. It's measured in hours. It's important that they put the units there because battery life, what does that mean if it's not in units of time? So they list the units of time there. Very good. We know that there are meaningful units. Therefore, it is quantitative. Operating system. The operating system is categorical, all right? Just like manufacturer, the operating system we use is categorical. Performance score, it is quantitative, and it's measured in, wait a second, there aren't meaningful units. It's a performance score, 0 to 100. 0 to 100 what? Well, this is an ordinal variable. It's like a quantitative variable, all right? So We thought it was quantitative, perhaps. It's like a quantitative variable, but it has no meaningful units, all right? Sometimes we can analyze these guys as a quantitative variable, but we need to be careful, all right? This is an ordinal variable. This is a good example of an ordinal variable. There is a meaningful order to the values, but without meaningful units, all right? So I don't have a little pen here, but I could strike through that quantitative. I could say that is ordinal, all right? Now, I mean, there's meaning to values that were given, but no meaningful units. Clearly, a 5 is better than a 1, all right? We're very much on the low end of performance score there. Clearly, a performance score of 5 is better than a performance score of 1. But do we know it's 5 times better than a performance score of 1? That is completely unknown. There are no meaningful units for which to make that designation. Right, now the why that we're doing this study. Why are we doing this study? Well, perhaps to provide consumers with info to help them choose the right tablet for them. Nothing complicated.